systems. Now, this is actually a straight cool condenser, not the heat pump condenser, but that's okay because all the features that we're going to be talking about are common between the heat pump and straight cool. We're going to go over some of the features of the condensing unit. We'll go over some troubleshooting. Then we'll talk about some of the different alarms and alerts. We'll talk about some of the different calculation formulas. We'll go over the air handler. Bit of everything. This is not meant to be an in-depth technical class, but we are going to hit on some of the main things that you'll see out in the field, some of the stuff that you're going to want to test when you're out in the field. So first, I've already taken the cover off of this condensing unit, but I do want to go over some of the features that are inherent to all the Ruud condensing units, even some of the commercial equipment that we're getting into on the splits, all basically have this new body style. We boast that we have one of the largest access panels here in the industry. That's 15 inches wide with a couple of screws right down here. This whole panel lifts and comes out. There's enough wiring in there that you can slide this whole panel over here to the right. There's also enough wiring on the condenser fan lid that when you remove the screws around the lid, you can remove the lid, flip it over and lay it down beside the side of the condensing unit. All the Ruud units have this base pan on it now, this polymer base pan, where you have a finger grip here. You've got slots for your screws. They have drain weep holes in them for your water. You have what they call their 3, 4, 5 valve, where basically 3 inches between the valves, 4 inches from the ground up to the valves, and at least 5 to 6 inches here above the valves. You also have an access window here. With this access window, you can remove 2 screws and you're able to put your test instruments up inside the unit and run the unit without having this big panel removed. Okay, those are all features that are common to the Ruud, all the Ruud units. You also have these single panels here. I've already removed the screws. On the smaller units, you just have 1 screw here to remove these panels. On some of the larger units, you're going to have a screw here, a screw here, and a screw here. But once you've removed those screws, the panels pull up and you can remove those all the way around for easier cleaning of the unit. Okay. You also will notice that these panels are slightly warped, and they're meant to be that way so that when they're put in here, there's grooves that they lock into. Then you have to twist it to lock it back up into the unit, which helps prevent any vibration that goes on in the unit. That's pretty much the features that I wanted to go over as far as what's common on all the Ruud condensing units, whether they're straight cool or heat pump. And as I said, as you get into some of the split commercial systems, you'll notice that they look a lot like these units as well. In fact, so do their new heat pump water pool heaters as well. Okay. Now in this unit, this is the inverter. This is your inverter board. A lot of people get scared when they open this thing up just because there's so much stuff there to look at. They wonder how they're ever going to troubleshoot it. And it's really a whole lot easier than it looks. And we're going to go through some of the different steps to do that with. On your panel inside, Gary, you tell me if we can see that. You're going to have your wiring diagram, your ladder diagram. You're going to have your charging chart here, okay? And you're going to have a gross charging chart and a subcooling charging chart, okay? Now, in the inverter systems, they're a little bit different on the charge. You definitely want to have the system run for a good 15 minutes before you make any adjustments to the charge. And then when you make those adjustments to the charge, you want to make sure that you do it slowly, that you make wait minutes. Tell you that I instruct all my contractors to do. I find it best when you're planning these jobs, if you can, go back the next day. Start up the unit, run the unit with the charge that it comes with, let it run for 24 hours, come back and adjust the charge from there. When you're adjusting to the gross charge, Ruud wants you to be between 78 and 82 degrees on your indoor ambient. Once you've adjusted that to the gross charge, which is on your chart, it's going to take you, I know it's probably very difficult to see. Can you see this here? Probably not. But this is basically your gross charge here. It's going to show you what unit you have up here, what tonnage, and then it's going to show you what your outdoor ambient is, and you run across and it's going to give you what your high side and low side gauges should be reading. Okay, that's just to get you close. Then from there, you're going to want to adjust the charge based on subcooling, and it'll give you, as you drop down in that chart, it's going to tell you how many degrees of subcooling that it's looking for. And it's very important thing that when you're making these adjustments, that you have the fan at full capacity, the condensing unit and the indoor blower at full capacity. Now, there's a charge feature in the Econet controller where you'll go into the system and you'll hit the button for charging, and it will ramp both systems to the appropriate settings for these. They want your indoor airflow design on the air handler to be between 375 and 450 CFM. So make sure that you account for that. Okay. As far as wiring goes on all the inverter systems, you can wire these what we call legacy wiring, but you really don't want to, because when you do, it basically takes the inverter system and it's going to turn it into a single stage unit, which is completely defeating the purpose of selling the inverter system. The only time you'd really want to do that if you have a problem with the Econet controller, if you've got an issue with, I don't know, just something that with communication maybe, where you would need to wire it up, legacy wiring in an emergency, so where you could get the system running until you can figure out what your other issue is. Okay. As far as wiring goes, we have 4 wires. We have an R common, an E1, and an E2. Those are the only 4 wires that you need to run from the indoor unit to the thermostat, and from the indoor unit to the outdoor unit. Okay. Those wires will connect right down here to these terminals here. You'll feed them up through the bottom here and then into these terminals. Now, obviously, when you're looking at these terminals, it would be very difficult to feed your wires up through here and try to feed them up under here and screw into these terminals. So these blocks are removable. You just want to make sure when you're pulling these off of here that you hold the board before you pull those off. If you just grab it and pull it, you risk pulling the whole board off, and we definitely don't want to do that. Now, on this one here, this is the communication block. Okay, and you'll see that there's an R there, but it says RT. You got E2 and E1. You want to make sure that you're not using the RT terminal. Okay, that's for when you're using shielded wire, and that's where you would terminate the shielded wire for R if you're using shielded wire. On the other plug that we have down here, this is where you're going to have your common and your R terminal on there. Those are the, so you're going to use those 2 on there, and then you're going to use the E1 and the E2 that's on the board there. Okay, your high voltage simply comes into here and goes right into here. Okay, be careful when you're screwing into there. That's a plastic junction joint there. So when you bring your high voltage wires in here, I've had a couple guys that are bearing down on these way too much, and you can risk stripping these, or sometimes they get loose and these wires at the top come out. And we'll get into a little bit more about the diagnostics there. Well, we'll actually kind of jump right into that now. As you're wiring the high voltage on this, as far as diagnosing the system, it's really not much to it. I mean, you're going to have your low voltage coming into here, so you want to make sure you've got 24 volts here, obviously. You should have lights blinking on the board. If you've got 24 volts coming into here and you don't have any of these lights blinking on the board, check your fuse, okay? If you've checked your fuse and your fuse is good and you've got 24 volts coming into here and you've got no lights, you have a bad board, okay? This is what's called the VSODU board, the variable speed outdoor unit board, okay? And this is what your different thermistors will connect to. This is what your fan connects to. This is what your pressure transducers connect to, all into this board. From here, you've got your high voltage that comes in, and the high voltage goes through these ferrite rings and comes right into the filter board, okay? So you're going to test for high voltage here, 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 high voltage here. If you have that all the way through, okay, then these boards and your system is not operating, then you either got a failure between this board and the compressor, or you have failure in this filter board, which I don't think has ever happened yet. I don't know that we've ever had to replace this filter board. We've replaced this board. We're actually on the second or third version of this board. This board is a board that they program at the factory to do different things. Some of the early units that came out, this didn't have as big a tolerance for the brownouts that we have here in Florida. So that's been fixed on the newer boards to where it's got a much greater tolerance to the brownouts that are here. Okay. This is your ferrite rings, your filter board. This all leads up to a choke. This choke all goes into the inverter board. And then this is your voltage that goes out to the compressor. Okay. So all these ferrite rings, the filter and the choke are all for cleaning up the voltage before we get to the board. Okay. So you're cleaning up the noise and the frequency, you're cleaning up the voltage, you're cleaning up the hertz, you're cleaning up everything so that we got a nice, clean 230-volt signal going into the board. Okay. For testing some of this stuff, you'll notice all of your small black wires are all thermistors. Okay. They're all either suction line thermistors, they're low or ambient thermistors, hot gas thermistors. They're all just sensing temperature. Okay. Hint number one on your test questions. Okay. All the thermistors on the indoor and outdoor units are 10K ohm thermistors. Okay. All the thermistors in the indoor and outdoor unit are 10K ohm thermistors. Now you'll have some thermistors that are wire. You'll have some thermistors that have a copper connection on them. Okay. But they're all 10K ohm thermistors. I think I've said that 3 times now. So hint, hint, hint. Okay. Now what that simply means is the 10K ohm thermistor chart is probably one of the most common thermistor charts there are. 10K ohms is going to equal 77 degrees. From there, your ohms reduce as your temperature gets higher, and the ohms increase as your temperature gets lower. So to verify whether or not your thermistors are operating properly, you're simply going to take your ohm meter. This, by the way, is my favorite. It's the new Fieldpiece SC680 available at your local Tropic Supply. Unfortunately, they are on back order, okay, like most everything else. But you'll put this on your ohm scale here. You can remove these plugs. You do not want to ohm these out while the plugs are attached, because you'll not only be reading the resistance of the thermistor, but any resistance you're picking up through the board. Okay. Then from there, you're definitely going to need needle point probes. These come with the meter. You're going to take these and you're going to insert those into the end here. We're at about, let's see, 11.33. Okay. That's 11.33. Let me see if I can turn the light on here. I don't know if you're going to be able to see that or not. So we're at 11.36K ohms. So if that's 11,360 ohms, if you were to take your 10K ohm chart and look at that, you're going to see that that's probably about 75 degrees, which is what we have the temperature at inside this room. Okay, so we test that. We know that that thermistor is fine. You can move right over to these 2 thermistors. You can move right over to this thermistor. Any of the thermistors you check, that's how you check them. Okay, it's that simple. Okay. One of the next features we'll go over on this is testing the blower motor. Testing the blower motor is really, really simple on these. You've got this blue and yellow wire right here. It goes to a tab that says fan. So you know that that's the fan motor. You'll simply unplug this and make a jumper between R and common, and jumper R and common to your blue and yellow wires here. Once you do that, the fan should run. Okay. If the fan does not run when you jumper that, then you're going to have to dig a little bit deeper. It would either be in this wiring or in this board. And you'd need to replace either or. But you can apply 24 volts directly to that plug, and your fan motor should spin. Okay. Now the board controls that, of course, so you don't want to just jump for that and leave it like that. Okay. Now, one of the next things that you're going to want to test after you're done needing tested thermistors or testing the fan is the next switch you got over here. I'm going to unplug this for right now, but this is your black, green, and red. This is your pressure transducer. You got a suction line pressure transducer and a liquid line pressure transducer. On the straight cool models, you're only going to have a suction line pressure transducer. On the heat pump models, you're going to have a liquid line and a suction line pressure transducer. Okay. You'll notice that the wires are red, green, and black. The red and black is voltage that comes from the board out to the transducer, and then a signal is sent from the transducer back to the board through the green wire. Okay. So when you're checking the voltage on, and we're going to go through that a little bit better when we get over to the air handler, because you can actually see the pressure transducer in the air handler. So we'll go into that in a little bit in depth, but the pressure transducer on the suction line is always going to be red, green, and black. On the liquid line, it's going to be red, purple, and black. Your red and black is always the voltage going from the board to the valve. And your green and black is your voltage coming back to the board. And that's DC voltage. Okay. That's volts DC. All right. And we'll talk about measuring that and how to calculate whether or not that transducer is good or not. Okay. From there, you're going to have on the heat pump models, you're going to have stepper motors that go to the electronic expansion valves. The nice thing about the electronic expansion valves is that it's the same valve on all the condensing units, and it's the same valve in all the air handlers. So it's a very simple valve. For those of you that aren't familiar, let's move over here real quick. For those of you that aren't familiar with electronic expansion valve, it's really quite simple. You've got like a bulb here, and then you've got a port that usually comes out to the side and a port that comes out to the bottom. On the outdoor condensing units, they're a swept connection, and on the indoor units, they're a screw-on connection. All this is inside here is a screw, and that screw has a motor magnet that sits on top of there. There's your wires, and it rotates that screw, either opens it or closes it, moving it clockwise or counterclockwise. Okay. So if you're ever having to test this valve, for example, if you're in the cooling mode and you suspect you have a valve failure in the heat pump unit in the outdoor unit, if we're in the cooling mode, the valve in the outdoor unit should be wide open. Okay. So if you take a temperature reading on this and a temperature reading here, they should be the same. If they're not the same, then you either have a restriction in the valve or your valve is partially closed. We'll get into a little bit more in depth on the motor, testing the motor as well, again, when we move over to the air handler, because you can see it over there. There's, I think, 5 wires that go to each motor, but a real simple way to know if your motor's good, cycle off power to the outdoor unit, turn power back on, and you should hear your motor going click, 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 click. Okay. That's it opening, closing, finding its range. Okay. So the valves are really simple. They're a whole lot less complicated internally than what a regular expansion valve is. There's basically only one moving part. So it's just a much more reliable valve than what our traditional expansion valves are on your regular units. Let's see, do I have anything else on here that I want to go over? Oh, yes. Okay, so testing the compressor. It's basically on our inverter systems, we're converting AC voltage to DC voltage. I should have said this from the onset. Please make sure that you're using protective gear, that you're very well aware of the high voltage that's in here, because you not only have high AC voltage, but you also have high DC voltage, which is deadly. Okay. So you need to be very careful. Make sure that you're aware of your voltage that's in here. These are your compressor terminals down here, your U, your V, and your W. These go out to your compressor. So if you need to ohm out the compressor, you're simply going to pull these off of here. Okay. You're going to, again, put your meter to the ohm scale. And you're just going to ohm out each one to itself. And they should all be about the same. All right, let me get these in here. 0.76, 0.77, and then we want to go from black to red, should be the same. 0.78. Okay, so as long as they're all close in range like that, then your compressor is ohmed out just fine on that. And just like any other compressor, you can also check at the ground by checking from each one of the wires to a piece of the copper tubing inside or what have you to make sure that you're good there on your compressor. Okay, so again, it's nothing real difficult on testing any of these. Just remember the 10K ohm thermistors. That chart is available to you just about anywhere online. There's also several of those programs that we use that have that available there. When you get an error code, all right, we're going to jump up to here. Okay, we have two types of alarms or two types of error codes. You're going to have alarms and you're going to have alerts. Okay, all your error codes that start with an A are alarms. If they start with a T, they're an alert. Sorry, let's back up a minute. There's three places that you can read error codes. You have an error code, a double-digit LED display that's on the board out here. Okay. You also have readouts on the indoor air handler with blinking lights. But I will tell you right now, the number one place to read the error codes is on the Econet controller. The Econet controller, these are just going to give you blinking lights. The condensing unit is just going to give you a 2-digit code, but the Econet controller is going to give you a much more detailed alarm or alert. Now, the difference between an alarm and an alert is an alert is just going to make you aware of a situation that could impede the operation of the system. Maybe the filter is starting to get clogged up. Maybe that you had slightly low voltage, but an alert is usually not going to take the system offline. Okay, it will try to correct itself and continue to operate. An alarm, on the other hand, will take the system offline. It may not take it offline right away, but it may be like a 3 strikes you're out type of rule where it's going to try to continue to operate. But if it continues to get that same alarm 3 times within the course of a single call for cooling operation, it's more than likely going to take that system offline. It may even try to start the system up again later, but eventually an alarm will take the system offline and you'll have to figure out what the issue is and resolve that issue. This is an example of a code that you might see. It's very important when you're sending these codes to us to help you diagnose what's going on with the system that you give us the whole code. Okay, a lot of times we'll get a guy or somebody will call in and we'll say, what's your error code? And they'll say, oh, it was a 916 error code. Okay, well, we don't know if it was an alarm or an alert, and we don't know where it went to. This, at the end of the code here, this _O, this is what that refers to. Okay, and Nicole, I'm sorry, I'm rambling on here. Nicole was going to put this up. I don't know if she's done that yet, but she's going to put this up on the screen to make it a little bit easier to see. But if your code ends in an A, it refers to the air handler. If it ends in a C, it's a communication error. If it ends in an F, it's a furnace in your furnace. O is for outdoor unit, S is for system, Z is for zone. Okay, so your first digit is going to tell us whether or not it's an alarm or an alert. This is what the actual alarm or alert is, and this can be in multiple sections. So we may not only have a 916 for the air handler, but we may also have it for the outdoor unit. We may also have it for the furnace. So we don't want to have to chase this down If you just give us what's at the end of the error code, it will tell us exactly where to look. Now, where do we find these error codes? Okay. Easiest place to find them is if you have the Ruud Contractor app. You can download the Ruud Contractor app in the App Store or in the Google Play Store. You'll log into it using your same login as your myruud.com login. If you don't have a myruud.com login, you can reach out to your local HVAC consultant or your local Tropic Supply, and we can get you connected to that. When you're looking in there, there's an Econet technician section that lists every alarm, and it also tells you what to do to correct it, step by step by step by step. If you need help beyond that, if you've been to, let's back up a second. If you've been to any of our inverter training classes, you're going to get this book, okay? In the back of the book, it lists several of the codes, but it also has these QR codes, and the QR codes are links to videos that show you how to test and how to do the videos. It'll walk you through the testing to do, for example, on the thermistors that we did, and what we're going to walk through here in a little bit on the pressure transducers. There's also your 10K ohm charges inside here if you don't have one that's downloaded on your phone. Excuse me just a second. Are there any questions so far? Okay, I'm going to keep moving then. All right, so 10K ohm thermistors. A is for alarm, T is for alert. The underscore O tells us where we're looking for the alarm. Okay. Now from here, we're going to move over to the air handler. Again, looking at the air handler can be intimidating because there's a ton of wires in here. Unfortunately, the only reason we have to have a ton of wires in here is we have to have availability to connect this legacy wiring as well. There's 7 wires that you'll need to connect to the thermostat in case you weren't using our Econet controller, which again should only not be used in emergency. Other than that, you always want to use the Econet controller. Okay. So when you're connecting your 4 wires to here, you're going to have these top 2 wires on this plug here is a brown wire with a white tracer and a purple wire. Those are your 2 communicating wires, E1 and E2. And then off of the other plug, you're going to have your red wire for R and your solid brown wire for common. Those are your 4 wires you're going to be using. Now, in addition to that, you're going to be using 2 extra wires here. So the next 2 wires down, or the next 3 wires actually, you've got, they're labeled AUXC, AUX1, and AUX2. Okay, that's your auxiliary common, your auxiliary 1, and your auxiliary 2. Okay, now what you're going to use those for is your float switch. All right, so we do not want you breaking R or common, and we do not, most definitely don't want you breaking E1 or E2, the communication wires. So you'll simply take one side of your float switch and wire it to auxiliary C, and the second side to auxiliary 1. And then through steps in the Econet controller, you'll be able to find those auxiliary tabs and label them as float switch. So now, unlike your most conventional systems, now if the float switch trips, it's going to say on the controller, it'll say float switch. So when your homeowner contacts you because their system's not operating, they'll be able to let you know that they have a float switch situation that needs to be addressed. Okay. Now, same thing here. If you look at this, try to jump over here. We're going to come down to here. All right. So this is the same stuff that we were talking about a little bit earlier. All right. So we have a thermistor here that's for the expansion valve. Again, you want it. This is just loosely zip tied here. You're going to cut that zip tie, pull this out of here, braze your lines in, and then you're going to attach this. The air handler comes with some insulation and stuff to wrap that thermistor on the pipe once you're done. But again, this is a 10K ohm thermistor. There's a couple ways you can test this thermistor. One, you're going to use your amp meter, pull it off the board and ohm it out and make sure that it's reading close to what you have on your pipe temperature. If you want to see if it's fluctuating properly, just like sometimes we do with regular expansion valve bulbs, you can take this and stir it in some ice water, get it down to 32 degrees, and see that it's reading the proper ohms that you would read at 32 degrees on a 10K ohm scale. Okay. This is the pressure transducer that we talked about. Your suction pressure transducer, you got your red, green, and black wires here. Okay, they come up to here onto the board. Now to test these, you're going to want to make sure you've got power to the board. Once you have power to the board, you're going to take your probes and you're going to measure the output from here, from the red to the black, and make sure you should be getting 5 volts DC from the board to the pressure transducer. And then from the pressure transducer back to the board, between the black and green wire, you should be getting between 0.5 and 4.5 volts. Okay, so 5 volts to the pressure transducer, okay, and then 0.5 to 4.5 back to the board. Now, if you're getting that voltage, you know that the board is functioning properly, that your voltage is functioning properly, but we still don't know if those voltages are reading the correct pressure on the suction line. Okay, so let's jump up over to here. Now, of course, we do not expect you to remember this or memorize this. These are formulas that we can send you. In fact, again, Nicole's going to try to put this up while I'm going through this because I know this
Todd.
Yeah.
All right, go ahead, Tim. There's a question.
Yeah, there is a question. When you have on the error codes, O stands for outdoor, A stands for air handler. I had a question: what is the S for system? What does that mean?
Well, same thing. It would be a failure that's it may be something related to the wiring going from through the system. There could be several different system codes. I can't. I was going to look it up on my phone, but so when you look under system, you just have to see what they are. I honestly, that's one that I've rarely run into. So I'm not even familiar with what some of the system codes would be listed under there. When you go into the Ruud contractor app, what I usually do is when you go to the Econet technician section, you can look at the alarm codes under each of those categories. I find it easier to scroll down to the bottom, and there's a section that says all alarm codes, and you can go to that section, and I can usually find them much faster through there. The majority of the codes we get are going to be either communication failures or thermistor failures. And occasionally we have some failures that run from the main inverter board to the compressor. But I would say the majority of the ones that I see are thermistor failures. I do have an example of an S code. An S code at A004_S, it stands for static pressure. So I'm assuming S is going to stand for total system error versus pinpointing or outdoor versus indoor. Yes, thank you for bringing that up. Static pressure. The chart on these in the book will go up to 1.0 static pressure. Of course, we want you staying in the 0.5 static pressure range best you can. All right, so back to the formulas. Now, this is, like I said, very confusing. We can send these 2 formulas out to you. You're going to have one for your suction pressure transducer and one for your liquid pressure transducer. The formula is PSI, atmospheric pressure, is 375 times your voltage out divided by your voltage in minus 22.8. Okay, we don't expect you to memorize this, but if you want to check to make sure the suction pressure transducer is actually reading the correct pressure, okay, because you can, you may have a reading on your gauge of a suction pressure of 137, okay, but there might be clog right where the pressure transducer mounts to that pipe. So the pressure transducer may be reading a far lower pressure from that pipe than what's actually in that pipe. And that's going to throw your whole system off if you have that error. Hopefully you're brazing with nitrogen and low flowing nitrogen, so you won't get those clogs. but in case you do. Now this voltage out, remember, this is where it gets confusing because I just talked about voltage out from the board. When we're measuring the pressure transducer, we want voltage out from the pressure transducer. So our voltage out is going to be between the black and green wire reading back to the board. So that's going to be your lower voltage. Remember, we said that was our 0.5 to 4.5 volts DC. And then the voltage into the pressure transducer is the 5 volts that we're getting from the board. Okay, so we take 375 times 2.1 divided by 5 minus 22.8 gives us 375 times 0.42 minus 22.8. So it's 157.5 minus 22.8 equals 134.7. Now that's PSIA. So adjust from PSIA to PSIG, we need to subtract 14.7 PSI. Okay, so 134.7 minus the 14.7 equals 120 PSIG. And that's what you should be reading on your suction pressure gauge or real close to it, allotting for the distance between the interconnecting tubing from the indoor unit to the outdoor unit. Okay, any questions on that formula? I know it's a lot, but again, we can send this out to you so you have that formula. Anytime you need these formulas, you can reach out to myself, you can reach out to Tim Murphy, Brad Evans. Those are our 2 tech support guys. They're very well versed in this equipment as well, but those are your formulas. Now, the only difference between the suction formula and the liquid formula is our numbers change. We calculate it the same way, except we go from 375 to 812.5 times voltage out, voltage in. Again, this is voltage out of the transducer, not the board. Voltage out of the transducer divided by the voltage coming into the transducer. And again, this is voltage DC, hint, hint, voltage DC minus 66.55. So if we were to plug those same formulas into there, get our reading in atmospheric pressure minus 14.7, that would tell you what your liquid pressure transducer is reading. And you would measure that against what you're reading on your liquid line. Okay. Any questions there? All right, let's back up to the air handler again. All right, so some of the nice things on the air handler is, again, remember earlier I said that basically all the evaporator expansion valves are the same, and all the condenser, or I mean, all the evaporator expansion valves or EEVs are the same, and all the condenser EEVs are the same. So it doesn't matter, straight cool heat pump, doesn't matter the tonnage, they're all the same. The good thing about that is that means the stepper motor that's on here is also the same stepper motor on all of them, okay? So if you suspect that you have a bad stepper motor, you do have the option of pulling the one off of the outdoor unit and swapping it for the one on the indoor unit, okay? Can get you out of a bind on that. When you're checking the stepper motor, you're going to follow this plug back up to the board, and it's probably kind of hard to see, but you've got this plug right here that's a gray, black, yellow, red, and orange. Okay, you're going to pull that off of there. Okay, and you're going to go to your ohm scale, and you're going to basically, and I'll just do a couple of these, but you're going to ohm out everything back to gray. Get in there. So we got 46.6, go to the next one. 46.6, go to the next one. 46.6, go to the last one. 46.6. Okay, so as long as they all ohm out back to the gray wire the same, then your stepper motor should be fine. At least it's ohming out fine. And again, shutting it off, shutting power off to the unit, turning power back onto the unit, you should hear this stepper motor clicking. Okay, there are ways that you can force these valves open or closed. you can pop these stepper motors off of there. There's a couple of companies out there that make EEV magnets. They're usually in 2 different sizes that cover almost every manufacturer and almost every valve. And it's basically a round magnetic valve. Now you got to be careful that you get the EEV magnets, because there's also a solenoid magnet that functions differently than an EEV magnet. But the EEV magnet, you can slide it over, pull that stepper motor off, slide the EEV magnet over that expansion valve stem where the motor is, and then you can turn that magnet and it will open and or close that valve. So you can adjust, not adjust, but you can open or close that valve in a pinch. Can't tell you off the top of my head who sells those, but we can get that information to you. We can get those. They're a great tool to have on there. Trying to think if there's anything else that I'm missing. Again, your thermistors. Oh, this communication chip on the board right here. There's one on the indoor unit and there's one on the outdoor unit. Okay. They are tethered with a wire strap because those stay with the unit. So if you have to replace the board, you're going to remove that, replace the board, and put that back in. Okay. Let's talk about the blower motor. Okay. So the blower motor, it's a variable speed blower motor. Can you come over here and catch these clips? Okay, so really the only way that you're going to be able to test this blower motor is if you have something like a Zebra tool or the TechMate tester, and you simply plug the TechMate tester into here, plug it into the motor. You attach it to your low voltage and click the button and your fan motor should come on. Okay, now some of the more advanced Zebra tools will give you more information than that, but that's really what you're going to do to check the fan motor. And then just like any other variable speed fan motor, you can remove the end bell, disconnect the wiring between the module and the motor, which is 3 wires. You're going to ohm each wire to itself, and they should all read the same. And then you're going to ohm each wire to ground for resistance, and they should all be open. If any of them are less than 100,000 ohms, I believe it is, then you've got to shorten the motor. Okay, that's standard procedure on any variable speed motor. Not specific to this air handler. Okay, that's just a standard procedure on that. It's in your Gen Tech books that you can find any information on that. Trying to think if there's anything else. Again, we talked about on the EEVs, test the EEVs. If we're in heating mode, the indoor EEV, of course, should be bypassed. So you would take a temperature reading of your line coming in and out, okay? And there should be the same temperature reading there. If you want to check it in the cooling mode, you should definitely see a difference between here and here, because now you're metering through here. And I think that's about it. Like we talked about, here's thermistor wires. You're going to remove the thermistor wires. You're going to test those when they're not on the unit, okay? Not attached to the board. That's all I've got. Are there any questions, Tim?
Yes, Todd, I have a question regarding the formula. It was regarding the formula. The question is, what happens if the ambient changes and you find the same number? So I think the formula you have to do when the system is running, correct?
Well, the system doesn't necessarily have to be running, but you at least have to have pressure. Okay, so what this formula is calculating is the pressure of the line. So even if the system's not running, there should be pressure in that line. If the system's been off for a while and the valves are open, you should have an equalized pressure between your liquid line and suction line, but you're still going to have pressure. Okay, so you're still going to plug it into this formula. Okay, the power needs to be to the unit so you can read your DC voltage going out of the transducer and into the transducer. Okay, but the formula is going to be the same. And of course, this is probably going to end up reading different than what you have on your gauges, because not the gauges, all the gauges are not going to be calibrated exactly alike. And we don't want you using gauges, but that's a whole nother class. We're going to get you into hopefully using nothing but temperature clamps and hygrometers when you're checking these systems. Once the system's been installed and commissioned, you should never have to put a manifold on it again, but we'll talk about that in another class. But this should be close to what you're reading, okay? If you're having to check this, if you're reading 120 here and your manifold set is reading 57, okay, then there's a problem. If you're reading 57 here, but your manifold's reading 120, then you've got a problem. If you're reading 120 here, your manifold's reading 118 or 123 or 125, then you don't have an issue. Okay. So this is meant to give you an exact reading. Well, it is, but I mean, that's what the valve's reading, but just realize you just need it to be close to what your manifold's reading, okay? Because again, where you're checking this is at the coil here, but your gauge is reading out of the outdoor unit, okay? So there's going to be a difference in that pressure simply because of the line set length and where your line's running through, whether it's running through a chase pipe that might be filled with water or you're running through a hot attic. So there will be some difference that you have to, of course, account for. Way you would account for that is you're going to take your temperature clamp on probes and you're going to check your line temperature at the outdoor unit, check your line temperatures at the indoor unit. That'll give you an idea of whether or not you have any of those issues. Water in the chase pipe, dent in your copper line that's reducing the pressure, line going through a hot attic that's picking up heat, maybe flashing gas before it even gets to the evaporator, so on and so forth.
Okay, got another one for you. It's regarding compressor lube error. It says, the question is, the compressor lube error, the main error seen when there is a transducer or thermistor issue.
Say that again.
Is the compressor lube error the main error seen when there is a transducer or thermistor issue?
No.
Okay.
No.
Okay.
No.
So what would a compressor lube error? What would one want to look for?
I'm not sure what he means by compressor lube error.
And Todd, that's John Manning who's asking, just so you know.
John, I told you you weren't allowed. I don't know. I'm not sure what you're referring to by what you mean there, John. But no, that shouldn't be involved with the pressure transducer or the thermistor. If you're talking about a compressor communication failure, sometimes that can be the connection between the board and the unit. One thing I did touch on the back of this board is a very big heat sink on the back of this entire board inside here. So when you're doing your preventative maintenance on these, you want to make sure you clean that. Don't be careful spraying a whole bunch of water on there to clean it. I would rather you use the deep bristled soft brush to brush through that and comb that off of there just to clean the spider webs, the cobwebs, the mud daubers, whatever else is getting in there to block that up. Okay.
We also have Hensley Thompson. Hensley, you've raised your hand, but if you could add your question to the chat box, we'd be happy to answer your question. John says he's 2 for 2 on that error.
Okay.
What,
yeah, but John, last time, John, remember you ended up replacing the thermistor, the pressure transducer, and the board, right? And you're supposed to test all three so we know which it is.
All right, we're going to take the John Manning, Tod Sutherland conversation offline. Are we ready to do trivia questions while we're waiting for Hensley?
What John will attest to is these are great running units. We love them. They're nice. They're quiet. Don't be afraid to diagnose them. Reach out to us. We can easily help you. Download the contractor app. Okay, download the Ruud contractor app. It's got a wealth of information on these units. Okay. All right, yes, so let's move on to the questions. And somebody will have to
Okay,
read
wait,
them out because I can't
Hensley.
see them.
Hensley's question is, with the older Prestige system, it's normally 0.6 volts DC from the control board to the motor. Is it the same with the new ones?
No. No. No, and it wasn't DC, it's AC voltage. So, well, again, are you talking about the indoor blower motor or the outdoor motor? Because on the outdoor motor, on the older Prestige systems, you also had a blue and yellow wire that you could also jumper 24 volts to on that and get the fan motor running. Okay. But no, both of these motors are just like the variable speed motors that you have on your like RHMV air handler, where they're AC voltage, not DC voltage.
He says indoor blower.
Yeah, no, they're AC voltage.
Okay, Hensley, let us know if we answered your question. And while we're waiting for that, Nicole,
right.
do you want to read the trivia questions? And I will see who does the first question right.
All right, hopefully I'll put the answers right. What's question
boy.
number one?
Let's see here.
Hint, hint.
Okay, question number one. The thermistors in the inverter condensers and air handlers are A, 20K ohm, B, 10K ohm, C, 20K ohm, or D, 5 VDC. 2. When testing the pressure transducer, your meter should be set to, I can read them, A, VDC, B, VAC, C, amps, D, ohms. Okay, question 3. The EEV motor on the indoor unit is interchangeable with the outdoor unit. True or false? Okay, question 4. The alarm code
Hey, can we wait?
A927_0 tells us A, alarm is in the air handler, B, alert is in the air handler, C, alarm is in the outdoor unit, or D, alert is in the outdoor unit.
Okay, and while we were
So
talking
that's-
just a second ago on the pressure transducers, again, keep in mind that this pressure transducer plug that we had on the air handler, that's your red, green, and black wire, that pressure transducer can be popped off of that valve and interchanged with the one that's in the outdoor unit as well. Okay, so there's a lot of common parts that are used on these. So when you're out in the field and you're trying to troubleshoot this stuff and you're trying to get a system up and running, mainly on the heat pumps, because we don't have a lot of the same on the straight cool units. But like on the heat pumps, if we were having a problem with the wiring on this pressure transducer, we could pull the one off of the outdoor unit and move it to the indoor unit. Okay, same thing with the stepper motor. Yes,
Is there a Schrader valve on that pressure transducer?
yes,
Okay.
yes, yes, yes. There better be. Yes, there is. All right, that's all we have. If there's no more questions, thank you for tuning in. If you have any questions, comments, what have you, please let us know. We want to try to make these better for you. So if there's anything we can change, if there's any of you that want a more in-depth class on this, please let us know. We'll get Wade from the factory to come down and do a class from the factory where you'll get one of these books and have these books available to you. So if there's nothing else, we're going to end it here.